Welcome to your online source for calculator tutorials. In this tutorial, we will learn how to use spacetime to perform random experiments for the purpose of investigating empirical probabilities. Begin a new spacetime document so that your screen looks like mine. In this tutorial, we will arrange it so that our calculator will perform 100 tosses of a fair coin and record the results. Before we get into setting up this experiment, we need to describe two commands which will be of some help. They are the floor and ceiling commands. These commands behave like a rounding command. For examples of these, go into your catalog and scroll to the C's first, and we'll look at the ceiling command. The ceiling command is CEIL followed by a parentheses and a Z. Go ahead and select this command. Alright, the ceiling of a number like 1.3, for example, would be 2. And the reason is because what the ceiling command does is it takes whatever number you enter and it rounds it up to the next highest whole number. Now go into the catalog and select the floor button. The floor command works exactly the same. In this case, the floor of something like 1.8, if you solved for it, would be 1. And that's because 1.8 is the next lowest whole number. So think of the floor and ceiling commands as being commands which round up to the next whole number or round down to the lowest whole number. Except it's not really like rounding, because if you were to round something like 1.8, you would round it up to 2, but the floor command takes it down to 1. Alright, now that we have those taken care of, back to the task at hand, we want to simulate the tossing of a fair coin 100 times. To do this, we need to have the calculator randomly create some numbers for us, and then we'll use those numbers in a clever way. In order to do this, we need to introduce the random command. So go into your catalog, scroll down to the R's, and find the command random. The random command takes two arguments. The first argument is the minimum value, and the second argument is the maximum value. For example, if I typed in 1, 10 and hit solve, the result would be a random number between 1 and 10. As you can see, this number can and usually will be a decimal. Well, how does this figure into the problem that we want to solve? That is, forcing the calculator to create 100 trials of tossing a fair coin. Well, if we let 1 equal a head and 2 be equal to tails, then we could use the following command to simulate the toss of a coin. Go in and I'll select the ceiling. And within the ceiling, I want to place the random command, so I need to go back into the catalog. And I want to randomly have the calculator always choose numbers between, in this case, 0 and 2. Now, why 0 and 2? Well, any number between 0 and 2 with the ceiling command is going to get rounded up to a 1 or to a 2, which is exactly what we want, because a 1 represents a heads and a 2 represents a tails. Now all we have to do is figure out a way to get the calculator to do this 100 times. Well, that's fairly easy to do as well, because the random command has a third optional argument. So if I insert another comma here, then the third argument tells the calculator how many times to do this. For example, if I type in 100, what this then does is it tells the calculator to repeat this trial, or this command, of picking a number between 0 and 2 and then rounding it up 100 times, which is exactly what we want. So go ahead and hit the solve button, and what you notice is you get this list of a lot of different 1s and 2s, exactly what we wanted. However, what we should have done is we should have named the list before it was created. So here's what we're going to do. Let's go back up and select entry number 4. Go into your menu button, and we want to copy this entry. And we'll go ahead and paste this entry down into entry 5. And at the beginning of the entry, what we want to do is give it a name. So we'll call this list 1 is equal to whatever the output of this command is. This is how you create lists in spacetime. We've seen this on previous tutorials. So my list 1 is equal to all these 2's and 1's that come out. So go ahead and hit solve. Once again, it creates a list of 2's and 1's, and it stores that list to the name list 1. Alright, well that's great. It's exactly what we wanted to have happen, but how can we use these results? Well, what we would like to do with these results is look at them in a bar graph or some other easy to recognize way of looking at the data. This can also be easily done in spacetime. Once you have your list of the random values 1 and 2, simply go into the catalog command and look for the command listplot. This command right here. Simply click on it, and the first thing you want to tell it is what your first data list is. In this case, our first data list was list 1, so I'm just going to retype in the name of that variable, list 1. And then the second argument that I want to use is I want to tell it what type of plot to return. In this case, the type of plot, and you do actually type type, type, is equal to, I want it to be a bar graph. So I go in and I type bar. And that's all you need. So list plot, list 1, type equal bar. And once you have that, go ahead and hit plot. What you'll notice is that it creates a bar graph. It works just like any other graph within spacetime. It can be manipulated the same. I can go in, double click on it to open it up. I can zoom in, zoom out. So here's a pretty good view of it. And what it shows me is the first is obviously the number of 1's or the number of heads. So that looks, if this is 40, 50, 60, so somewhere between 60 and 70. And the number of tails is slightly less than 40. Then we can double click, return back, and look at any of the different things that we want to look at here. All right, this concludes the empirical trials tutorial. Feel free to replay this tutorial or browse any of the other available topics on the course webpage.